Hello, I'm Wendy Athens, and I am an online chemistry instructor at Florida Southwestern State College. For my capstone project, I would like to describe the redesign of the laboratory component of Chem 2025, Introduction to Chemistry. Thank you for the opportunity to speak with you, and I look forward to your feedback. I'll discuss the instructional goals of the redesign, the literature support for the changes that I made, the overall course sequence, the before and after, the results, and note that this course ended last week, so I have fresh data, and my evaluation and future plans for this online course. This slide provides some interesting background information to Chem 2025L. First of all, I'll note that the Dean and Science Chair remain very negative about online labs. My predecessors were fired because of their poor track record, both for low success rates and slow response times. I inherited an online course that was structurally sound but relied completely on virtual labs within LateNiteLabs. I'll provide an image of the LateNiteLab interface in a moment. This past spring was the first time I ran the course, and I didn't change it. But this summer, simultaneous with taking this SloanCOnlineLabMastery series, I have been redesigning the lab portion. I've retained many of the LateNiteLabs, but I've added a kitchen lab and a video-based lab. Before I go into the changes that I made, I'd first like to introduce those that are unfamiliar to LateNiteLabs. LateNiteLabs is a very good virtual lab system. It provides a realistic interface, which the literature tells us is important. There are containers, materials, and instruments at the student's disposal, and they can bring them down onto the lab bench to work with them. There are a few problems that I've noticed with LateNiteLabs, however. I never know if the student is actually doing the work. That is, someone else could be submitting the work for them, or they might be copying it from a file that someone gave them from a previous semester. While it's important to have an organized online course, I also felt that it was repetitive and routine to do LateNiteLabs week after week after week. I thought it was important to incorporate hands-on and video experiences as well. Those were some of my motivations for redesigning the course. I have research support for these decisions. The first two articles focus on why I would deviate from a 100% virtual lab approach. This Souter article emphasizes the importance of realistic interfaces and that simulations aren't as realistic as remote labs, and certainly not as realistic as a hands-on kitchen lab. The Ma Nickerson article says an interesting thing, namely that a student needs the hands-on lab before they can fully appreciate the simulation. Finally, besides the modality in which the lab is rendered, I show an article on peer evaluation of labs. I was introduced to this article through this Sloan C course and immediately incorporated the peer evaluation element into the redesign. The article states that students are too lenient in providing feedback unless they have a model score from the instructor. Then they will provide much more constructive feedback. This slide shows all of the labs and activities that the Chem 2025L students completed this summer. The two orange labs are the redesigned ones. The first is the kitchen lab, and the second is the video-based titration lab. I'm going to focus on this starred kitchen lab today. This is the kitchen lab. The student was to make a set of 5 solutions of varying concentrations with the goal of achieving a parts per million concentration for the most dilute solution. Students submitted a video describing the procedure and calculations. They also submitted a formal lab report. Here are the parameters that I gave to the students. They had to come up with a colored compound and determine the volumes and masses with some precision. The students and I exchanged a lot of ideas through email about their procedures. I did not set up a discussion board for the students to discuss possible procedures, but it's a good idea. This would be similar to the way they would work in a face-to-face lab with their lab partner. Here's one of the better student submissions, the video and the formal lab report. Students had prior access to the grading rubric. I also provided a lab report template to make my expectations clear. Now that I'm entering my second semester of offering this lab, I can offer a model report and video to show the students, and I believe this will improve the quality. After students submitted their work to me and while I was grading their projects, I kept them occupied by reviewing another student's work. That is, I randomly paired the students. I had the students submit the feedback on this Google form. This was the idea that I pulled directly from the Georgia Tech Physics MOOC article. A quick score sheet works well, especially if students see how the instructor scores a sample. Next semester, I will be able to provide that example. The other change I will make is to require the peer review before the final submission to me so that students can improve from peer feedback before they are graded. Out of the 17 students who submitted their work, 4 did not submit anything. Most of them were successful. I define success as earning at least a C or meeting expectations on the learning outcomes. Right here is the video score, here's the report score, and these are the 6 learning outcomes that I was measuring. These are detailed over here on the side. There were 2 students who struggled with the technology aspect, or they didn't explain all of the calculations. I know that I could support video creation better next time. Regarding peer review, it was as lenient as the research article led us to believe it would be. There was no discrimination, even though you saw in the previous slide that I had scored 2 students as not meeting expectations. Note also that 4 students did not submit the peer review, and they were not penalized for this, although I think next time I will do so. In summary, when I considered what worked well and what needs improvement about this redesign, I would say the positives are these. I loved seeing my students at work and having a more holistic assessment of their grasp of concepts and techniques. It was great to use simple materials to practice a very useful skill. I also tried to use this lab experience to impress on them how very dilute parts per million is and relate it to EPA limits on water pollutants. It was good that I gave students 2 weeks to complete the work and weighted it equivalent to 4 of the late night labs. What would I change about this project? I've already stated that peer review should precede my grading, and I look forward to showing examples next time before students submit their work. I'll also add a survey at the end, so I have more specific feedback about the exercise. The most important conclusion that I made is that this exercise is valuable and worth the 2 weeks of instructional time. I will offer it again in improved form. Thank you very much for listening, and I value your questions and feedback.